do. This is definitely an advanced question. So with this problem, you're going to notice that you have a function within a function. And when you have that, that's the chain rule eventually, or reverse chain rule. So that gives you a heads up if you're going to do U substitution. So we're actually going to do U substitution and integration by parts all in one step. So I am going to need some room on this. This is kind of an extensive problem. Okay, so definitely a good one to have me help with. So I'm probably going to do most of it. So I'm going to start my work over here. So step one, we have to do U substitution. I'm going to have to make this marker a little bit thinner to make this happen. Okay, so U substitution, since natural log of x is on the inside, I'm going to make it U. And then when you derive that, you get 1 over x dx. And then remember, we solve for dx, and that gets us x du. All right, so we end up with cosine of u times x du. And the one issue we run into is that we have this x right here. And if you remember from U substitution, it has to be all in terms of u. So we have to take this right here and solve for x. So throwing, I want to say throwing it back, but you guys will yell at me. So throw back to pre-calculus. You have to solve for x here. And when we solve for x with natural logs, we raise everything to the e power. And we do that because it gets rid of this natural log. So it cancels out the ln and e, leaving you with e to the u equals x. I'm going to highlight that. Okay. So what happens then is that takes the place. So now you really have cosine of u times e to the u du, which makes it look like it's more complicated, but I promise it's actually going to help us. So the second step we have to do is actually the integration by parts. So this right here, I'm going to highlight it in blue. Just remember, this is now what we're trying to integrate. So we have to figure out the whole u and du and the dv and the v using that little LIA acronym. So cosine is trig, e to the u is exponential, so trig is going to be the cosine of u is going to be our u, and the dv is going to be the e to the u du. Remember, we're integrating with everything with respect to u. So the only problem with this is we've talked about how when you integrate e to the u, it just goes e to the u. And when you go cosine, it goes to sine, and then it goes to cosine. So this is one of those oscillating problems. So you're going to have to integrate it actually twice and solve, but then it actually is not that bad from there. So like I said, this is kind of a good question to ask on this problem. This one's a little tough. So we integrate u, and you get negative sine of u, and if you integrate e to the u, just get e to the u. So that leaves us with cosine of u times e to the u minus e to the u negative sine u, and it would be du. I just didn't write it. Okay, and we're back to what we started. So if you, not back to where we started, sorry, we're back to another integration by parts. Now this right here is going to cancel out, so we really have a positive. I'm going to go like that, so I don't have to write it twice. And now you have to do the integration by parts again. So it's really similar to the last one. The reason we have to do it is because we're stuck. We still don't have anything that works. You're doing all of the same thing. The only thing is this is sine here instead of cosine. And this is e to the u, so it's e to the u. Wow, that looks bad. Du. No, it's not. Back up. That du doesn't go there. And if you integrate sine, or derive it, sorry, if you derive sine, you get cosine of u du. So we take all of this, and we're putting it down here. So cosine of u times eu stays, and then we have to do minus because, sorry, not minus, the plus sign stays, and then we're going to do this whole integration by parts. So we're going to do sine of u and e to the u. Sorry, this is looking really atrocious. And then minus e to the u cosine u du. Well, what you should notice that right here is what we're trying to do, and it is exactly the same as what our last integral is, what we just wrote. So if you remember when we did this, I'm going to see if I can select this all. No, I can't. Okay. We set it equal to. So I'm gonna be lazy because I can. Oh, good Lord, at least, of course I did that. Okay, not doing that. I'm gonna cover up some of this work. Okay, so I have room. If you remember, we set the integral that we're trying to find equal to what we currently have. So, I would write it over here, but I don't think I can write it wide enough. So I'm gonna go down here. Step 4, highlighter. Step 4, we're gonna take the integral we're solving for and write it equal to what we currently have. Oops. All right, and hopefully while I'm writing this, you kind of remember what you're going to do from here. So what we're going to do is we're going to add this over right there to the other over here. And I'm too lazy to write it. Okay, so that leaves us with 2 and the integral of cosine of u e to the u du equals cosine of u e to the u plus sine u eu. Never wanted to write this so many times. You're going to divide by that by 2, and you get it equaling 1/2 cosine of u e to the u plus 1/2 sine u e to the u. And the last thing you do is you're going to go back to what you substituted and had u as originally, which is right here, and we're going to plug it in. So wherever there's a u, we're going to plug in the natural log of x. And just because I don't want to write it, I don't even care that that's a highlighter, just because I don't want to write it, you're going to be plugging this natural log of x into the e. So if you remember from the beginning and from pre-calc, these cancel out and just leave you x. So anytime I plug that into right here, it's going to result in x when you plug in that natural log. I just don't feel like writing that more than I have to. So 1/2 cosine of the natural log of x times x plus 1/2 sine of the natural log of x times x. I left some space so you know. In my key, I have the x in here, and that's how I would write it to end, but I just don't feel like writing it again. So that is your answer. That's it. Not an easy problem. So definitely a good question to ask about. All right. Hope that helped. Bye.